Assalamualaikum. Hi, my name is Muhammad Iqmal bin Abdul Talib and my matrix number is 08DKM21F2012. Today, me and my groupmate, which is Muhammad Razif, Muhammad Wafi Zihni and Arif Ridwan, will be talking about differentiation. First thing, we must know about differentiation. Differentiation is all about finding rate of change of one quantity compared to another. We need differentiation when the rate of change is not constant. There are four basic rules of differentiation, which is the first one is constant rule, the second one is power rule, the third one is constant multiple rule, and lastly sum rule. And there are three techniques of solving problems in differentiation. The first one is product rule, second one is quotient rule, and the third one is chain rule. We will talk about stationary points and rate of change. I will be explaining about stationary points. Some application of differentiations includes tangents and normal, Newton methods, rate of change, finding maximum and minimum points, and curve sketching. In this subtopic, we will discuss on how to find stationary points using differentiation and sketch the graph. There are three types of stationary points. The first one, which is maximum point, the second is minimum point, and point of inflection is the third one. You can see in the picture given. Next, I will be talking about minimum, maximum, and point of inflection. If d power 2y over dx power 2 is bigger than 0, it is minimum point. Then, if d power 2y over dx power 2 is smaller than 0, it is a maximum point. And the last one is if d power 2y over dx power 2 equals to 0, it is a point of inflection. Next, I will be passing to my colleague Muhammad Razif for further explanation and example.
Assalamualaikum, my name is Muhammad Razif bin Tajo Arifin. My matrix number is 08DKM21F2028. Now I will show you the example of stationary point. The equation given is y equals to 3x squared minus 18x minus 7. So to find the stationary point, we need to differentiate the equation. So it will be y prime equals to 6x minus 18. Okay, now we need to find the value of x. So the y prime, we change it to 0. So it will be 0 equals to 6x minus 18. So the value of x is 3. Now to find the value of y, we need to change the value of x to be 3. So y equals to 3 times 3 square minus dengan 18 times 3 minus 7. So the value of y is negative 34. In conclusion, the stationary point is 3, 34. Now we need to define the types of stationary point. So to find the type of stationary point, we need to double differentiate the differentiate we get. So we will get y prime prime equals to 6. Because of 6 is more than 0, so our stationary point is minimum point. Now we need to sketch the curve. So to sketching the curve, we need the value of x and value of y. So we need to find the value y. So the value of x will be 0. So the equation is y equals to 3 times 0 square minus 18 times 0 minus 7. So we get the value of y is negative 7. Now to find the value of x, the value of y will be 0. So 0 equals to 3x square minus 18x minus 7. After do a calculation, we get the value of x is 6.37 and negative 0.37. Okay, after we get the stationary point, the types of stationary, the value of x, the value of y. so we can easily sketch the curve. So as you can see on the picture, you can see the sketching of curve that I already do. So at there we got the value of x, value of x2, value of y, and the value of minimum point. So that's all from me. Thank you.
Rate of change, one of the more important application of derivative or differentiation is to calculate rate of changes. It allows us to find the rate of change of area with respect to time. For example, there is a circle with r, so that is the radius. So the formula is dA over dt equals to dA over to dr times dr over dt. So you will remove the dr on top and on the bottom to make the dA over dt.
Rate of change is divided into two, one variable and two variables. One variable is used in a problem that involves only one variable, such as the height of a shape is increasing or decreasing, while two variable is used in a problem involving two variables. For example, the height and the radius of the shape is increasing or decreasing, respectively. An example for one variable rate of change question is: the surface of a sphere is increasing at the constant rate of 10 pi centimeter square per second. Find the rate of change of the volume when the radius is 10 centimeter, given A and V. So the surface area of the sphere is increasing at a constant rate, so the 10 pi is positive. So they want us to find dV over dt. The formula for dV over dt is dV over dr times dr over dt. So the first step is to list all the informations. The second step is to find dV over dt. So from the formula V, 4 over 3 pi r cubed, the differentiation for that equation is 4 pi r square. And when we substitute r is equals to 10, we get 400 pi. So that's the first part that we need to find. And the third part is we have to find dr over dt. Now from the A formula, which is 4 pi r square, the derivative of that formula is 8 pi r. Now we substitute r, 10 centimeters, into that equation, gives us 80 pi. So that's dA over dr. So if we want dr over dt, so we have to get dr over dA first, which is 1 over 80 pi. So in conclusion, dr over dt is equals to dr over dA times dA over dt. Now we have dr over dA, and dA over dt is given by the question. So 1 over 80 pi times 10 pi, which gives us 1 over 8. And now the last step is to find dV over dt. Now that we have dV over dr and dr over dt. dV over dr is 400 pi, dr over dt is 1 over 8. We'll multiply and we get 50 pi centimeter cube per second. And that's the final answer. Now for the example for two variables, the question is: the height of the cylinder is 10 centimeter and increases at the rate of 1.2 centimeter per second. The radius of the cylinder is 5.7 centimeter and decreases at the rate of 0.8 centimeter per second. Calculate the rate of change for the volume of the cylinder given volume. So the first step of answering this question is to list down all the information. So the question gives us dH over dt, which is 1.2, and dr over dt, which is decreasing, which is negative 0.8. So the second step is to find dV over dH. Now from the equation volume that the question gave us, pi r square h, the delta of the equation in respect to h is pi r square. And when we substitute r equals to 5.7 centimeter into the equation pi r square, we get 32.49 pi. Now that's delta v over delta h. Now to find dv over dr from the equation v pi r square h, the delta for v over r is in respect to r, so any derivative of h is cancelled and is equals to 0. So ultimately the equation is 2 pi r h. Now there's r and h in the equation, so when we substitute r and h respectively, so the delta v over delta r is 114 pi. Now we can find dv over dt. So there's a formula in two variables to find dv over dt, which is delta v over delta h times dh over dt plus delta v over delta r times dr over dt. Now dh over dt and dr over dt, the question already gave us. We did find delta v over delta h and delta v over delta r, so we can now use this equation to find dv over dt. So delta v over delta h is 32.49 pi times 1.2 dh over dt plus delta v over delta r, which is 114 pi, times dr over dt, which is decreasing, so it's negative 0.8. And finally we get the answer, which is negative 52.22 pi centimeter cube per second for the rate of change of volume of the cylinder. Thank you very much for listening to our presentation. Assalamualaikum and good night.